Hello everyone, welcome to chapter 5 hydrocarbons. So hydrocarbon, it means in that compound, it consists of hydrogen atoms and carbon atoms. So it's classified into aliphatics and aromatic. So focus on this aliphatic hydrocarbon is what we are going to study in chapter 5. So which is categorized into saturated hydrocarbon. Saturated, it means that in this hydrocarbon, it contains only single bonds, which refer to alkane cycloalkane. For aliphatic hydrocarbons also, we can have unsaturated hydrocarbon. So the unsaturated hydrocarbon means that in this hydrocarbon, it contains multiple bond. It's either carbon-carbon double bond or carbon-carbon triple bond, which we have alkenes, cycloalkenes, and alkynes. So for saturated hydrocarbon, we are going to cover it in chapter 5.1. For alkene, cycloalkene will be covered in chapter 5.2. Okay, so the next category we have aromatic hydrocarbon. So an aromatic hydrocarbon, still we have hydrogens and carbon, and it has an aromatic ring acid functional group. So the examples over here, we have our benzene, which will be covered in chapter 6. So in the overview for you, a benzene structures. Alright, so first of all, let's just look at chapter 5.1 alkanes. With the naming of the alkanes, we call it as the IUPAC Nomenclature. So this is the naming of an alkane. So by the end of the lesson, this is the learning outcome for you to check your understanding. So first of all alkane will have the ane suffix. Suffix means that the name of the alkane will end with ane. General formula CnH2n plus 2. So over here you can see a straight change alkane, which means this alkane has no branch, or this is the backbone of the carbon chain. So the straight change alkane, if you only have one carbon atom, we name it as methane with the formula of CH4, one carbons only. Two carbon ethane with a formula H6, C3H8, C4H10, and etc. Okay, so we have methane, ethane, propane, butane, pentane, and then 6 carbon hexane, heptane, octane, nonane, decane. So you have to memorize all these 10 first alkenes here. So you can realize that the parent name, the straight change over here, all of them end with the words A and E. So if it is a straight change alkyl groups, that means it is an unbranched substituents. So this will be the carbon substituents that bonded to a long carbon chain, okay, which remove already one hydrogen from the original alkene. So in this example, if you have only one carbon substituents, instead of CH4, remove one hydrogen, it becomes CH3, become the substituents. And the name is called as methyl, okay, and with YL. Okay, and then if you have two carbons, the alkyl group substituent CH3, CH2, and then connect to the main carbon chain, it becomes ethyl. The original name is ethane. So after removing one hydrogen, become ethyl, and with YL. So whenever you see the YL, methyl, ethyl, propyl, butyl, pentyl, ending with YL, it means this is an alkyl group substituent. The next one, we have the branch alkyl group substituents. Branch substituents, that means inside the substituents, it has another substituents. Okay, so the numbering will always begin at the point where the group is attached to the parent chain. So we start off using 3 carbon in your substituents alkyl group. So the structures look like this: CH3, CH, CH3, and then this bonding will connect to the parent chain. So the name of these structures is called isopropyl or 1-methyl ethyl. So the positions 1-methyl, it means at this carbon parent chain, this is your carbon number 1. Okay, this is your carbon number 2, and then methyl behave as the substituent. So 1-methyl ethyl. Or another word is isopropyl. So if let's say I take an example, this one is my carbon chain. I have no idea how many carbons are they. But if I can see this structure CH3 connect to CH, CH3, this is called as isopropyl. Okay, or if you have a branching, so for example, okay, the branching look like this. Yeah, so you can see this is an isopropyl, okay, condensed form and then skeletal form. This one is just my parent chain, so I use a giggle line, okay, to represent my parent chain. If there's 4 carbon in the substituent, it depends on how the carbon inside the substituents is arranged. If that is the case like this, that means this carbon is connected to the carbon chain, the main carbon parent. Okay, so this will be your carbon 1, 2, 3, and you have a substituent. So following IUPAC naming, it is 1-methyl propyl, 1-methyl propyl, or the common name we call it as the sec-butyl. Sec over here refer to secondary. Okay, this one refer to secondary as the carbon that's attached to the parent is a secondary carbon. So this carbon number 1 is a secondary carbon. Okay, so if using symbol, I will write it like this to represent the parent. So it will be, if I convert this way, CH3, CH, CH2, CH3. So you can try to see the structures like this. But of course, the main parent, it will have more than 4 carbon, okay, in order to be the parent. Or another symbol using skeletal structures, it looks something like this. Okay, in which we have carbon 1, 2, 3, 4. Okay, the carbon that's attached to the parent is a secondary carbon. So this is a secondary carbon. Okay, a secondary carbon. So another example, if my substituent locate at the second carbon. Okay, so I label this one as carbon 1, which attached directly to the parent, carbon 2, carbon 3, and I'll have the substituent CH3. So for this IUPAC naming is 2-methyl propyl, position at number 2. Or another name we call it as isobutyl. Okay, isobutyl. Okay, so if you look at the structures in condensed form, we will see something like this, which attach to your CH2, CH, CH3, and you have a substituent at your carbon 2. Okay, using skeletal structures, it looks something like this. Iso, it try to means that at the end over here, you have 2 CH3 groups. So this is your isobutyl. 4 carbons altogether, carbon 1, 2, 3, 4. So 4 carbons altogether. Okay, and then the next example here still we have 3 carbon, and then this is connected to the main carbon chain. So this is carbon 1, this is carbon 2. So at this time we have 2 substituents at carbon 1 in your substituents. So it becomes 1,1-dimethyl ethyl. Or another term we call it a third butyl. Third over here means a tertiary. So that means the carbon which attached to your parent chain is a tertiary carbon, which we have 1, 2, 3 carbon neighbors. So tertiary butyl because of 4 carbon. So looking at the structures, okay, I can make it this way. It's either you put 3 branching of CH3, okay, or I condense straight away into 3 CH3 group. Or in skeletal structures, it looks kind of like the chicken leg, okay, in which we have a tertiary carbon which attached to 3 carbon neighbor CH3, CH3, CH3. So altogether 1, 2, 3, 4, 4 carbon. There are 5 carbon in that substituent. So according to IUPAC naming, you have 1-methyl butyl or sec-pentyl. Sec over here means secondary, in which this carbon number 1 which attached to the parent is a secondary carbon. Okay, this is a secondary carbon with 1 branching. So 1-methyl butyl or sec-pentyl. Pentyl means you have 5 carbon. So I'm going to show you the skeletal structures. It looks something like this. 1, 2, 3, 4, 5. So altogether 5 carbon. 1, 2, 3, 4, 5. The carbons that connect to the main parent is a secondary carbon. If it is isopentyl, iso it means at the end it must look like a leaflet. Okay, that means it as carbon 1, 2, 3. This one is at carbon number 3, so we have 3-methyl butyl. Okay, butyl as the main chain in the substituents here, it has 4 carbon. So the skeletal structures, okay, it look like something like this. 1 carbon, 2, and then 3, and open up the leaflet, it looks something like this. So carbon 1, 2, 3, 4, 5. So whenever you see this structure, okay, this is iso. Pentyl because of 5 carbon. 1, 2, 3, 4, 5. 5 carbon. And the next example here we have a third pentyl. Okay, third means tertiary, so that means the carbon which attach directly to the parent is the tertiary carbon. So following IUPAC naming, it's called 1,1-dimethyl propyl. Di because you have two methyl group attached to the same carbon 1. Okay, so 1,1-dimethyl propyl, or the third pentyl. Okay, the structures look like this, in which the carbon that is attached to your parent chain is a tertiary carbon. Okay, and then 1, 2, 3, 4, another carbon which is direct attached to another branching here. You can either here, this one, or this one. Okay, so make sure there is 5 carbons altogether. 1, 2, 3, 4, 5. And the last one we call it as the neon pentyl. Neon, it means that for this carbon, you have the IUPAC naming is 2,2-dimethyl, in which the carbon, the branching, located at carbon number 2 in this substituents. So looking at the skeletal structures, it looks something like this. A slightly longer chicken leg. Okay, remember that the one that Madam draw in giggle line here, it means the parent chain. So here is a guideline. So first of all, find the longest carbon chain, which is the parent. If there are two chains with equal length, pick the chain with more substituents. Second, we need to number the parent chain. Put the number 1, 2, 3, 4, 5. Depends how many carbon we have. So try to give the first substituents with a lower number. If the first substituent is the same distance from both ends, we will number the chain to give the second substituents the lowest number. And if there are two different substituents and they are the same for both ends of the main chain, we want to assign the lower number alphabetically to the first substituents. So that means if the positions are the same for both the left-hand side and the right-hand side, we will follow alphabet A, B, C, D, E. Okay, depends on which end will start first. And then next, number 3, write the name as a single word with no space in between. So between number and letter, we use the hyphen, dash. Between numbers and number, we use the comma. So each number will indicate the positions of your substituent. If let's say you have 2 substituents, you are going to have 2 number. 3 substituents, 3 number, and so on. And then lastly, if there are 2 or more substituents, make sure all substituent has a number. Okay, different substituents, you need to arrange and follow the alphabetical arrow A until Z. If it is the identical substituents, we are going to use prefixes. So these prefixes will be ignored when we arrange the alphabet's order. Alright, so the prefixes is given in the table. If let's say you have 2 same substituent, we will name it as di, 3 same substituent name as tri, 4 similar substituents tetra. If there is 5, we call it penta, 6 we call it hexa, 7 we call it hepta. So all these prefixes, you are going to ignore the letters when you arrange the alphabets. So that means we are not going to consider the D, the T, the T. So for example, which will be considered in alphabetical order, beside the names of the substituents, if you have the term iso, isopropyl, isobutyl, and so on, the terms, the letter I, okay, for neon, the letter N will be considered in your alphabetical order. But for the third, the sec, the tertiary, secondary, the T and S, does not consider the T and S in alphabetical order. Okay, including these prefixes. So prefixes and also the positions of the carbon are not considered. So let's look at the example questions 1. Name the following alkanes. First of all, let's find your parent. Parent should have the longest carbon chain. Okay, whichever is closer to your substituent. So obviously, if you look at this one, it's closer from the right-hand side. So here we got carbon 1, 2, 3, 4, and 5. So this will be your carbon main chain, which is consists of 5 carbon. So the parent name will be pentane. Okay, the parent name is pentane. And then for these two substituents, one located at carbon 2, another one located at carbon 3, and both are the same. Okay, remember one substituents will have one location, one number. Okay, since they are the same, so position 2 and 3, it become 2, 3, number and number using comma. Okay, 2, 3, and the prefixes that we are using is di because of two groups. So it becomes dimethyl pentane. Okay, no spacings. Alright, so 2, 3, dimethyl pentane, no spacing in between. Between number and number, comma, between number and letter with a hyphen dash. Okay, another second examples over here. So we can try to label down. If let's say I start 1, 2, 3, 4, 5, 6, 7, 8. Okay, the main carbon chain here got 8 carbons. At the first substituents over here, I can look at here, we get carbon 4 and carbon 7. So let's try using another sign. If I label as carbon 1, 2, 3, 4, 5, 6, 7, and 8. So carbon 2, you will look at you can first see your substituents. Okay, so preferable using the label, the numbering from our right hand side instead of the red color one. Okay, so position 2 and 5. Okay, substituents 2 and 5. The one using red color, okay, is position 4 and 7. Okay, position 4 and 7. That's why we are choosing the lowest set possible. Okay, start from the one with blue color. So we start with the naming. If you can identify the substituents, you can name it first. At positions 2, here we have a methyl group with only one carbon, substituents, methyl. And over here you can see a branching. So this branching with 3 carbon, okay, and you have C1, 2, 3 carbon instead. So this is actually the structure for isopropyl. Okay, isopropyl. So positions 2, we have methyl, start with the letter M. Positions 5, we have isopropyl, start with the letter I. So follow alphabetical order. I come first before M. So in your naming, it becomes 5-isopropyl. Okay, between numbers and letter using dash. And then the second substituents, then only we have 2-methyl. Follow the alphabetical order. And then finally, what is the name of the parent? Parent must come last. Okay, so 8 carbon is called octane. Okay, so the full names over here, 5-isopropyl, 2-methyl octane. Alright, so here are an extra questions for you. You might jot down somewhere around the notes that you have. So for the first structures over here, also we need to identify the parent. So try to figure out the longest carbon chain. If you can see here, carbon 1, carbon 2, carbon 3, carbon 4. If you circle this one as your parent chain, then you might got it wrong. Because the longest carbon chain, I can turn it upwards. It's not necessary to be a straight line. It can go up, so it can go down, as long as this is the longest carbon chain. Okay, so carbon 1, 2, 3, 4, 5, and 6 label it. So that means this is my main carbon chain with only 2 substituents, which is a carbon 2 and carbon 4. Okay, and because both of these substituents are the same, they are called methyl group. Okay, so our full name, it will be 2, 4. Each of them represent one methyl group. So we have 2 similar group and we use the prefixes di. Okay, it becomes dimethyl, and the parent chain, we have 6 carbons, so it will be hexane. Okay, 2,4-dimethyl hexane. So for this example, we try to figure out which one is the parent. Now you need to try and error. If let's say 1, 2, 3, 4, 5, 6, 7, and 8. Okay, you need to try and check one by one. So if let's say I start with 1, 2, 3, 4, 5, 6. Oh, you only got 6 carbons, so cannot. 1, 2, 3, 4, 5, 6, 7. 8, 7 carbon is missing 1, so this is still the longest. And try to figure out the positions of your substituent, which is at carbon 3, carbon 4, carbon 6. So I label here 3, 4, and also 6 with substituents. So I can also start from this carbon. Let's label as the blue color here. If I label as carbon 1, 2, 3, 4, 5, 6, 7, and 8. So the point that I'm going to have my substituent is 3, 5, and 6. Okay, 3, 5, and 6. So the first substituents from both ends is the same. So we look at the second number. So whichever is lowest, that is going to be your choice. So in this case, we prefer the first set, which is in red color. Okay, positions 3, 4, and 6 because they are the lowest set of number. Alright, so once you decide the lower sets of number, next we want to look at the order. Okay, remember first thing is to find your parent. The second thing is put your number. Okay, whichever end is closer to your substituents and it is the lowest. And then after that only we will arrange the alphabets. Okay, so carbon 3 and carbon 6, I have the same substituent, which is the methyl group. And then at carbon number 4, I have my isopropyl. Okay, I have my isopropyl. So comparing the letters, so over here I have an I have an N. So again, same thing, I was going to follow the alphabets with the I first and then after that N. So for the full names, okay, isopropyl is at carbon number 4. So I start off with 4-isopropyl. And then I have the substituents methyl group, which come next. And then I have 2 positions with 2 methyl group. So the positions 3 and 6. 2 methyl group, we have a di, the prefixes. So dimethyl. And finally, your parent with 8 carbons, which is an octane. So the names become 4-isopropyl, 4-isopropyl, 3,6-dimethyl, and octane. Example questions number 2. Draw the structures of a given compound. The first one, 5-isobutyl 2,4-dimethyl octane. You may either use condensed structures or skeletal structures. We will start off using the parent octane. It means you have 8 carbon. Alright, so draw your zigzag carbon with 8 carbons all together and then label it accordingly. Alright, and then put your substituents at these positions. 5, we have isobutyl. Okay, positions number 5, we have isobutyl. Remember that isobutyl, we have 4 carbon, and at the end, you should have a branching looking like this. Now, so 1, 2, 3, 4, 4 carbons all together. And then carbon 2 and 4, we have a methyl group. Remember, di means you have 2 groups of methyl. So positions 2, 1 methyl group, position 4, 1 methyl group. You may want to convert this one into condensed formula. Okay, and then for part B, 6-tert-butyl, tert means tertiary, and 3,6-dimethyl nonane. Okay, the parent nonane here means that it has 9 carbon. To arrange the alphabet, if you're looking this one, tert-butyl doesn't include in your alphabetical order. So we are looking at the alphabet B and M. The prefixes di, tri, tetra doesn't include the positions third or sec, the secondary carbon, doesn't include in your alphabetical order. Okay, so we start off with the nonane. So 9 carbons all together. And at carbon number 6, that is a tert-butyl. Butyl, you have 4 carbon, and then it is a tertiary carbon which attaches to a parent. So this is your parent, carbon number 6. You have a tertiary carbon with 4 carbons altogether. Tertiary carbon, 1, 2, 3, 4, 4 carbons altogether. So this is your tert-butyl. And carbon 3 and 6 dimethyl, 2 groups of methyls. Okay, so carbon 3 and 6, carbon 3, 1 methyl group, carbon 6, there's another methyl group. If you want to put this methyl group at the bottom, that's also fine. Just to keep in mind, 1 carbon maximum minimum, it must having for bonding. The one doesn't show, it means that it is attached to the hydrogen.